I'm CK, and tonight we have an interesting unit from our friends at Neutral Labs. It's their new Meg. It's a wave manipulator. Looks like it's going to be an interesting unit to play with, and hopefully it'll be a fun one to build. Hope you enjoy the video. Here's the box from Neutral Labs, a QR code which will go to the online manual. Version 1.1. No bubble wrap paper, I like that. I can recycle that. Little electrostatic bag with the chip, transistor, voltage regulator, eurorack power cable, a little bit short on that. Their old sticker, I've already got one of those. And here is a new sticker. It looks like it goes on your car window. I don't think I'll be using that though. Let's see what's in here. Here's a paper bag, which is the front panel. And input, output, and the typical ambiguous control indications, but you can see obviously we're doing some things to waves here, creating some interesting pulse widths, creating some interesting humps. I don't know, we'll see when we get it all together. Let's see what's in here, because one thing I don't see yet is circuit board, which is an important part of any electronics kit. Let me get rid of the box first. Oh, there's the circuit board. Fortunately, I didn't get rid of the box quite yet. So here we go. Let's look at the circuit board. It's a good board, through-hole plating, nice crisp traces. Here's the control side. And here's the electronic side. Doesn't look like a lot. Bunch of resistors, some diodes, some electrolytic capacitors, and the chip that's doing most of the work, that's the power connector. So it doesn't look like it's going to be too intense a build. Dump all the parts out. Make sure we didn't leave anything in the bag, and we did not. Bunch of resistors, as I said. Some control knobs, which I'll put aside for right now. Jacks, 2 pots. And that's pretty much it, and a jumper. Not sure what the jumper is going to be for, but we will certainly find out. So that's it. Again, it's not too complicated, not too big. Should be a relatively quick build. So I'll get the soldering iron heated up and we'll dive into it. We'll take a quick look at the build guide first. Nice parts list. Then step-by-steps. And as you can see, lots of pictures. Even for a relatively straightforward build like this, it's good to have lots of pictures. And of course, pretty quick. Not many pages. And we'll go through the build guide in the order he recommends, just because. Okay, he wants us to start by putting the diodes and all the 10K resistors on. So we'll dive into that, and we'll play that back in fast motion because there's not a lot of commentary to be had putting resistors and diodes on the board. That's resistor time for this kit. He says to go ahead and put everything on except R22 and R21 and R22, because to quote him, he says, get to it. They'll get special treatment later on, and if you look at the pads for R22 and R21, where'd it go? Over there. The special treatment is they're stand-up resistors, and you know how I dislike stand-up resistors. But that's okay. He doesn't want you to do them now because you're going to be laying the board flat, and stand-up resistors, it'll be rocking. You want to get everything else on the board first. Or you could just not do stand-up resistors. But that's just my personal feeling. Now I'll put the socket on. Make sure the notch goes in the right way. And we don't even have to muss with that much. The pins are reasonably tight, but we'll do what I do all the time on sockets anyway, which is solder one leg and pick it up, take a look, make sure everything is flat to the board and even, and it is, but I'll just double check by pressing firmly on it with my finger, reheating that little piece of solder, and everything's on the board. Now we'll do the two little caps. The one, there goes my stupid water heater. Okay, the water heater's off, and while we were gone, we have everything on the front side of the board. There are 3 transistors. These 2 are the same. This one is different, so be aware of that. And he points it out in the build guide. We've added the power header, and this 3-pin header is for this jumper, and you have to go to the manual to see what it does. It's for AC or DC coupled waveforms. So you'd put it in one position, AC position for audio waves if you want to manipulate audio waves, DC position if you're doing control voltage waves, or you could just not, as he says, you could just not have the jumper on. It'll do AC coupling and it'll still be interesting and work well. And of course he does talk about the 2 stand-up resistors, and they'll stand up instead of lying down, which is totally not because of space limitations on the PCB, but rather in order to better absorb cosmic energy. He's acknowledging that stand-up resistors are because they were last-minute additions, fixing something, or whatever, and I hate them, but we'll put them in. And the reason why I dislike them, just because I don't want to just rant for no good reason, is I find stand-up resistors to be error-prone, not in their installation necessarily, but since they are standing up, they are more susceptible to being bumped, bent, or otherwise maneuvered around the board, and I have seen them both short themselves to other components and ground themselves to the side of a jack or the side of a potentiometer, because you know, when they're standing up like that, you can bend them over if you're not careful. So I prefer a board that doesn't have any stand-up resistors if possible, but I understand sometimes you come back in and you've got your design done and you say, oh, I'm getting this transient, or I need to clamp this voltage a little bit, and you got to throw another resistor in and you don't have enough space, and you don't want to relay everything out because then things get all wacky. So I'm going to put the IC in next. Make sure the legs are good. Bend them a little bit inward on the side of my workbench so they go into the socket a little bit better. Find the notch. Look at the notch on the circuit board, not the notch on the socket, because sometimes you'll put a socket on wrong. I've done that. So if you actually look through and look on the circuit board itself, you'll always get it right. And I'm going to put the jumper on the AC coupled side because I expect, at least for the demo that we're going to be getting to, I'm going to be using it for audio signal processing. Now we're going to do the other bits and pieces that go on the front board. So the two pots are both they're both 10Ks, so we don't have to worry about messing that up. Now I'm going to fit the front panel on so we can see how everything looks. Everything's looking good. So with cradling it in my fingers, I'm going to do one pin down here. Oh, one thing you may also notice, because I haven't talked about it, is there are no LEDs on this board. Which is neither good nor bad, just is. What are we doing here, kids? Okay. I want to get this other jack on this end with one pin tacked. And those two jacks are down well. So I'll put panel nut on the two jacks that I soldered one leg down on. And that will hold everything in an aligned position. And I'll go ahead and solder all the rest of the connections on the jacks and the pots. Now, there's not much space here between the capacitor and these jack pins, so be careful you don't run your soldering iron into the capacitor. Okay, so that's it. Let me run these other panel nuts down. Okay, one last thing. I'm going to go through all the solder joints. Make sure everything is both soldered and looks good. Obviously I'm looking at the weep through the wicking to make sure it's penetrated all the way through the holes. So, get the power connector on. Red stripe to the position that says red stripe. Now a couple of knobs, and the hardest part for me, trying to get the index marks on the knob lined up with each other, which I'll probably get wrong, but it's not a biggie. Test the pots. They all swing, all swing. Test the jacks. All good. So that's the front of the unit. That's the back of the unit. Side, side, top, and bottom. Now we'll put it in the rack and see what she does. Alright, so it's in the rack. Powered up, no fires started. So let's do some baseline. Both knobs all the way down. You notice on the oscilloscope the yellow trace is unmodified. The magenta trace is modified, and I've made it a little bit shorter so they don't completely overlap. Now let's take everything up about half. Ooh. Well, that looks pretty neat, doesn't it? And sounds pretty neat. See the way the wave is. Let me take the width out. Take the wave all the way up. Starts folding a little bit. And then gets rather abrupt, then I go all the way up. Now we do them in concert with the width modulation. See that little sweepy thing it gets going? Take that way up. Take it way, way up. We're getting double peaks on that. So you can see, obviously graphically, you can see there's a huge difference from the input wave to the output wave. I'm going to try some modulation. Unfortunately, I don't have a LFO out here right now. But I will try triggering the notes with the sequencer. And where am I? There I am. I'm going to slow the sequencer down some. So that's what she does. Sounds pretty interesting. So you can see how this could be interesting to fold, or not. You're not folding waves back on themselves. You're shaping them. Read through the guide, and you get a good description of what he's talking about there. But it certainly adds some interesting character. Even though, I don't know if you're noticing this, when I turn this knob, I'm getting glitches. That's no good. The other knob doesn't do that. It's as if a cap is discharging. I don't know why it's doing that. Just wanted to drop in and mention that I sent the oscilloscope traces and some data about that little blip we just saw in the oscilloscope to neutral labs. They took a look at it, they looked at their schematic and did some testing of their own, and it's an expected behavior if there is no voltage active on the input signal and you sweep through there. There's a zero crossing point that's going to cause that. It's not going to happen when you have any actual input occurring. So when you're playing music or when you're sending CV through that, you're never going to experience it. It's just something that happens if you're at a completely non-powered state. So nothing to worry about. So a good little distortion unit that you can play with your waves, and you can see how it could be useful for control voltage too. Then I'd switch the jumpers to DC coupled for that. But again, since I don't have an LFO out here, I can't really do anything with that right now. But a quick build, less than an hour to put it together. And an interesting little unit, and another good one from Neutral Labs. Hope you enjoyed the video.